Maybe get the captain. That'd be great.
I feel like it's going to take 60 seconds.
And he's going to we're already ready for it. So, time to start. Alright guys, you ready to learn about Spacechains?
Yeah!
Spacechain is a more modest sidechain proposal than the better drivechain proposal. That's fancy and uses all sorts of cool stuff. Spacechain tries to be a little bit more modest. It's a proposal that was invented by my internet friend Ruben Thompson. And then, like a year ago, I launched the first Spacechain on testnet, so I'm going to do a presentation about that. And actually, we're going to launch one together as part of our workshop. So that's what we're going to do. Also, there's two little URLs up here in the corner, and I recommend that you visit these. So the first one, if you open it up in your browser, it will just take you to a copy of this presentation. I think some people find that useful to have a copy right in front of them so they can follow along and take notes or save it or whatever you like. And then this other one is the actual Spacechain launcher. So if you visit that one in your browser, this is what we're going to use to launch our Spacechain today. So if any of you want to skip ahead and just get right to that part, feel free to just load this up and start banging away. You can just click the buttons and see what happens, because it all works. Or at least I hope it all works. I haven't actually tested this in like 4 months, so it might not work anymore. But we'll find out when we get to that part. So, definitely do those. I will keep this little window up here in the top right, so that anyone who wants to can easily find the link and go ahead. All right, you guys ready to learn what Spacechains are?
Yeah!
No, we got one guy shaking his head. He's not ready. He's like, oh, this is too much. It's already too much. But we're going to go for it, man. I believe in you. Okay. So, what we will cover today? Well, Spacechains have two parts. They're defined by two significant attributes. One of them is blind merge mining. And I'm going to tell you how that works. Then we got the one-way price peg, which sucks. After that, we're going to learn how to do blind merge mining, because it's not enough to just know what it is. You also need to know how to do it. And that's what I think is the coolest part of Spacechains. Then I'm going to go over some use cases for them. Then we're going to compare one-way pegs versus two-way pegs and why the second one is better. That's what drivechain gets us. But you already learned that from Mr. Drivechain's talk. And then we're going to do the demo, where you can actually launch one of these things and make your own little Spacechain. So that's our agenda for today. Let's do it. Woo! Spoiler, there's new slides in this. The slideshow is identical to the one that I did 2 years ago, or not 2 years ago, a few months ago at Bitcoin++, but there's 2 new slides, and this is one of them. It's just telling you there's a new slide. It says, did we find a two-way peg? Did we find one? Because we've been searching for one in the Spacechain community, a way to do this without a soft fork. And no, we didn't. But we came kind of, maybe sort of a little bit close, sort of, not really. Spacechain's biggest problem is that we only have a two-way peg. I know you don't know what that is yet, but keep this slide in mind for when we get to that part. We only have one-way peg, and one-way pegs kind of suck. But we've maybe kind of found a good enough alternative. We have to try it out and see if it's any good. It's probably not very good. But we'll try it out. Okay, so now I want to tell you all about merge mining. And this is the first part of what a Spacechain is. Blind merge mining is one thing, and then the one-way price peg. So what's merge mining? Because blind merge mining is a type. Blind merge mining is a type of merge mining. What's merge mining in general? Well, merge mining solves a problem, which is that blockchains need to know the order of blocks. This was Satoshi's brilliant idea. We need to know the order of transactions, right? If I send money to him, I can at the same time send money to him. We've got to know the order. Who got it first, right? Brilliant idea. Why don't we make a chain? Why don't we just make a little chain of these things and have everyone keep a copy? That's what we do. But if you're going to have a blockchain, you need to have that. You need to have that order. And back when people started launching blockchains, in addition to Bitcoin, back when it started getting forks and stuff, there started to be problems. And some people were like, well, wait a minute, if we've already got a whole network of miners, Bitcoin miners, who are like creating blocks and ordering them, why should we create a whole second blockchain and have a whole set of other miners doing the same thing. Like, can't we reuse some of this work? Why do we have to have two different groups doing the same thing? So Satoshi came up with this idea called merge mining. And he knew, because he made Bitcoin, that Bitcoin, you can put data in it. And you can put information from other blockchains into Bitcoin. So this little block over here represents a Bitcoin block. And it's got two hashes in it. See that one says ABAB and the other one says CDCD? Those are hashes. Hash represents, it's like a fingerprint for a set of data. And well, two hashes, every Bitcoin block contains, when you do merge mining, every Bitcoin block contains two hashes. One of them represents all the transactions in the Bitcoin block. This is called Merkle root. And the other one, if you're doing merge mining, you just stick another hash right in the Bitcoin block that represents all the transactions happening on another blockchain. And it's really cool because Bitcoin doesn't care what you put in it. You can stick anything in there. You can put JPEG monkeys in there if you want to. You can sure as heck put a 32-byte hash. So you can put that in there, and then your other sidechain can just use Bitcoin's proof of work to say, okay, just follow that chain of hashes, and every time you see a new block, a new Bitcoin block, check that second hash there, and we'll know what the transaction order is in our blockchain. So merge mining is awesome. It saves you from having to have two different sets of miners, and it lets you just have a bunch of transactions on two different blockchains that all use the same miners to do the work. Merge mining is awesome. It saves you from having problems. But it brings problems. Everything has trade-offs, right? We're Bitcoiners, we know about trade-offs, and there are trade-offs with merge mining. First bad trade-off, miners need to run special software. That second hash there isn't getting in there for nothing. Miners got to have special software that inserts it in there. And how do they do that? They've got to run the second sidechain. They've got to run a whole other blockchain, and they've got to take all of its transactions, hash them, and then take that hash and put it in their Bitcoin block. And that's a lot of software to run. Miners don't like running extra software. They just want free money. Just like, hey, I'm already running software. Why can't I just get free money? Why do I do extra work? Sometimes I don't even want to do it. So that's a problem. If you're going to do regular merge mining, you need to convince miners to run your sidechain software. And also it helps proliferate altcoins. Every time you make a new blockchain, you need to pay miners for doing this work somehow. And typically you end up creating an altcoin to do it. And that's stupid. We only need one money. So regular merge mining brings these two problems, and blind merge mining is supposed to solve them. How does blind merge mining work? Well, by the way, is it safe now for me to get rid of this link up here? Just for those who came late, this link up at the top takes you to this presentation in case you want to copy on your own laptop. This one takes you to the demo where we're going to launch our own Spacechain. Does everyone have these two links? Or if we're all good? Okay, I'm going to get rid of that. Okay, so how does blind merge mining work? Well, actually I'm just telling you what it is in this slide. We'll talk about how it works in a minute. What it is it reverses those two problems. When you use blind merge mining, Bitcoin miners do not need any special software. They don't even actually know that the second hash from that previous slide is in the block. They don't even know it's in there. They're blind. They're like that guy. They got their blind glasses on and they're happy because they're getting free money. They don't even need to know anything's happening. They can still make money off of merge mining without doing any work, and that's pretty cool. But blind merge mining has been proposed through a soft fork. BIP 301, Mr. Drivechain, is he in here? Hey, Mr. Drivechain, raise your hand. No, he's not in here. He proposed using BIP 301 to do this, and then later, what's his name? Ruben Thompson figured out that you can also do it with sig patch no input, or opctv, or vault, and there's even a way to do it without a soft fork, which is really cool. There's some trade-offs, but it's the one I implemented because I love trade-offs. So I'm going to show you actually when we do our demo. I'm going to show you my version of Ruben Thompson's version of blind merge mining, which I implemented, the one that doesn't need a software. It's going to be great. It's going to be moving and shaking. So this is the promise of blind merge mining, if we can just find a way to do it. And I'm going to show you how we do it after I tell you about the one-way press peg. Because there's two things about Spacechains, right? There's the blind merge mining, and there's the one-way peg. Well, how does the one-way peg work? And what does it even do? Well, this part's the stupidest idea that Ruben Thompson ever came up with. That's not true, because he didn't actually come up with it. The people from Omni, I think, came up with this idea. But he uses it, and I don't know why. The idea of a one-way price peg is that you can create value by destroying them. You take a Bitcoin and you just give it a big old smack and you push it into this thing called an op return and your Bitcoin's gone. Isn't that great? You can destroy your Bitcoins. And when you do that, you create a permanent record that you don't have Bitcoin anymore. And from some people's perspective, that's valuable. It's like, hey, you took something that was scarce and you destroyed it. And you can only do that 21 million times. So there's a scarcity to that. So that's the idea, is that you can create something scarce by destroying Bitcoin. And if you do that, then you can use these records of having destroyed Bitcoin as if they were a currency. I know, this seems like, why would you do this? That's my thought. Never do this. But yeah, that's the proposal for Spacechains originally was, since we don't have a two-way peg, we don't have a way to get Bitcoins onto and off of a Spacechain, we'll just destroy them. And that'll be great. In theory, if you can always create your own space coins by destroying your own Bitcoins, then their price can never rise higher than the price of the Bitcoin. Because if they did, this scenario would happen. You know, she destroyed some of her Bitcoins, created these space coins, and she's like, hey, you should buy this for me for 1.2 Bitcoins. You know, she's raising the price of them. And this blue guy over here, he's like, you think I'm an idiot? I can destroy my own Bitcoins. So of course he's not going to do that. He's not going to buy something that he can just make himself. So that idea, I think, is kind of neat. The idea that if you do destroy your Bitcoins, you can like create a price cap where these other coins you create by doing that can't have more value than a Bitcoin. It like reduces the the speculation you can do on it. Creates a price ceiling. So that part is kind of cool, but I don't like the destroying Bitcoins part. Okay, so now we know, I think, what blind merge mining is, or at least what the promise of it is, and we know what a one-way price peg is supposed to be. And now I want to tell you how to do blind merge mining, because this is the part that really fascinated me. First of all, was like you can actually do this today, and you don't need a software to do this thing. So I talked about it earlier. I showed you that Bitcoin block that has 2 hashes in it. There's no reason why the second hash has to be created by a miner. All we really need to do is embrace the fact that anybody can put data into Bitcoin and just have anybody do it. Anyone can use this function in Bitcoin called an op return, which is also the thing you use to burn Bitcoin. But when you burn Bitcoin, or even if you don't burn Bitcoin, you can just add a piece of data in there. The op return, it's kind of like a Bitcoin address, but instead of having value in it, like if you do put value in it, the value is burned forever. But if you don't put value in it, it's just a piece of text. Because Bitcoin addresses are just text, right? So op returns are just like, you can put these things into Bitcoin, you can put text in them, and you don't put any money in them, because that would be stupid. But if you do, your money's gone forever. Those are op returns, and you can use them to embed data into Bitcoin. So that's what we do. Since we need to have this second hash in Bitcoin representing all the transactions on the sidechain, we just do that. Anybody can just take the transactions on the sidechain, create a hash of them, dump them in an op return, and now Bitcoin knows about them. And if you want to know the order of blocks on the sidechain, just look at Bitcoin. Bitcoin's got these op returns. They'll have they'll say what the order of transactions are, and then it's great. So anyone can make these. I want to show you guys a couple of examples of anybody making them. Over here, we've got Mempool Space, one of the best websites. And if you scroll down, this is an example of a Bitcoin transaction with an op return right there. And it's just got some random piece of text in there. If you look at the details, that op return looks like that. You see that? Nice little string of hex right there, 32 bytes. You guys who are programmers know we programmers love 32-byte strings. You can do anything with those. You can make them a fingerprint for a whole lot of data. This one in particular is a fingerprint for a sidechain block. This comes from Fiat Jeff's Soma Spacechain, Spacechain inspired open market for assets. He made a Spacechain on Registest, and or Signet, I mean. And this little op return right here contains a hash of all the transactions in that block of his, in one of the blocks of his sidechain. Kind of neat. doesn't have much, doesn't leave much of an impact on Bitcoin. It's just this tiny little thing that's about the size of a Bitcoin address. But yeah, you can use that to figure out the order of transactions on the Spacechain. Isn't that kind of neat? I like that. So anyone can make those things, and there's an example of one. But there is a little bit of a problem with blind merge mining, which is who creates the blocks. So with Fiat Jacks, he created this sidechain called SOMA. Spacechain Inspired Open Market for Assets. And every day he goes into his computer and he decides I'm going to make some sidechain blocks. And he creates these blocks, and he hashes them, and he puts the hash into Bitcoin, like I just showed you. And the next day he does it again. He makes some blocks, hashes them, puts them into Bitcoin, does it again, and it's great. But what happens if Fiat Jack dies, or gets hit by a bus, or the government tells him to stop doing it, or whatever? Well, it could be bad. Because maybe his sidechain just stops working and no one can use it anymore. Ordinary Bitcoin UTXOs can only be spent by one person. Fiat Jeff puts some money into this Bitcoin address. Only he is the one who can spend it, right? So only he's got the private key. Well, we want to fix that. We want to make it so that anyone can create new blocks. It doesn't just have to be like one guy who started this sidechain. We want it so that anyone can create sidechain blocks and keep the thing going, even if the person who started the sidechain dies, or just gets uninterested or whatever. So ordinarily, a Bitcoin UTXO can only be spent by one person. However, you can make an exception. We have these special types of Bitcoin addresses called anyone can spend. Has anyone ever used one of those before? Anyone can spend address? Yeah, that guy has. They're kind of neat. Anyone can spend addresses, you can put money in it, and then poof, it's gone. Nobody took it. So you can use those instead. Like instead of Fiat Jack putting money into a Bitcoin address that he's the only one who can spend from it. He could put one into one of these anyone can spend things, and then anyone could use that to make the next block. And that works. You can actually do that. One problem is anyone can spend it. So that guy is representing a thief who saw some of the money go into one of these addresses, and instead of creating a sidechain block, he was just like, how about I just take that money? So he ran off with it. You can't really prevent people from doing that unless you add soft fork. Covenant soft forks let you do this. They let you say, hey, if you're going to take money out of this address, you have to just put it right back in. I'll show you a little bit more about covenants later in this presentation. But one of the things they do is they let you change the nature of anyone can spend addresses, so that it's still true, anyone can spend it, but you have to make it like a cycle. It has to go right back into the same address over and over again. So covenants fix this problem, where you use anyone can spend addresses to make it so your sidechain can keep going after you're dead, but then someone can steal it. Add covenants, doesn't happen anymore. Covenants are awesome. Anyone in here a fan of covenants? Oh my goodness, everyone's a fan. All right, cool. So a little bit more detail about the anyone can spend model. This is the model that the sidechain we're going to make today uses. How it works is you want to make a Bitcoin address that you can track. You can track these transactions that go into and out of this Bitcoin address, because they're going to tell you about the sidechain blocks. They're going to each have a little output in them with a 32-byte string that tells you about the sidechain block. So to make one, you just create an anyone can spend address. This is a feature of Bitcoin that most people don't know how to use, but ask your local programmer and he'll tell you how to make one, and then he'll steal your money. You just make an anyone can spend address, and you put a tiny amount of Bitcoin in it. This 546 cents used to be the very minimum amount of Bitcoin you could put into a Bitcoin address. It has since been lowered to 294 is the new minimum, but I didn't update the slide because I like that number better. So you put that little tiny amount of Bitcoin into this address, and then it's not really worth it to steal it because it's like 3 cents. So that's what you do. You put that amount of Bitcoin into your Bitcoin address, into your anyone can spend address, and then you start spending it. You start creating Bitcoin transactions that take that money, spend it, put it right back into the same address, and in every one of those transactions you include an op return with a 32-byte string that represents your sidechain block. Just keep doing that over and over and over again, and everyone can follow your Spacechain. And anyone can even do this, that anyone can make their own sidechain blocks by just doing the same thing you're doing. It's awesome. It makes it so that even if you die, People can just keep your sidechain going. So these are linked lists. That's all blockchain really is a linked list. And we can put linked lists into Bitcoin by just following the transactions that go into and out of one of these anyone can spend addresses. Also, another cool thing about Bitcoin, if somebody does like reach in and take the 5 cents or whatever that's worth, you can detect that. You can detect that somebody took the money, and then you can be like, hey, you took the little dust output we were using to track our space chain. Naughty person. You know what we're going to do? We're going to ignore you. We're going to just put a new dust amount into that address and start going from there. Just pick up right where we left off. So the anyone can spend address lets you do that. It lets you just use a tiny little amount like that. It's not worth stealing to create a linked list of Bitcoin transactions and use that to track the order of blocks on your sidechain. Great. If somebody steals it, no big deal. The next person who wants to make a sidechain block will put a new dust amount into the address, and you'll pick up. Everyone will detect that and pick up from there. Another thing is that thefts ought to be rare under this anyone can spend model because they're expensive. Stealing 546 cents costs more than it's worth, especially when the people who are mining this sidechain, they're actually paid. They're paid to do it by means of sidechain fees, and so they're willing to spend some of their earnings to be the next guy to actually create one of these outputs. And so they actually can pay like $5 or $6 or even thousands of dollars if it was a very successful sidechain to be the one to move this little output right there. And so if a thief wanted to come along and take it, well, they'd have to like spend thousands of dollars to do that. All they'd get is a 546 Satoshi output, and they wouldn't even do anything because in the next block somebody would just make a new one. So it's not really worth stealing, and it's really expensive to steal. But if it happens, it's no big deal. You can just recover easily. So that's kind of nice. That's the anyone can spend model. It works today. You can use it for blind merge mining and create a Bitcoin sidechain where Bitcoin miners benefit. They get fees from people using this thing, but they don't even have to actually pay attention to it, which is nice. Okay, so that's the anyone can spend model, which is the one I use, and I'm going to show you. And then there's a couple other models for how to do space chains without software. This one used to be my least favorite. It's called the prepaid model. And it became cooler a few days ago, in my opinion. But the prepaid model involves more trust. So you create a group of people. Some group decides they want to start a sidechain. We call these people sponsors. Let's say there's 20 people or more. So these people make a huge multisig. And once they have their multisig, they raise some money. They say, we're going to start a sidechain. It's going to cost a certain amount of money to do this software stuff and pay developers or whatever. They crowdfund some sats and they put that money into like the starter address for the Spacechain. And in this model, they don't use an anyone can spend address. They use a multisig where all of these guys have the keys, all the sponsors. So they raise some money, put it all into the initial starting point address for this Spacechain. And once they have the money in there, they create a bunch of Bitcoin transactions that spend money from that initial address. And these Bitcoin transactions, they might create like a whole bunch of them, like 10,000 of them. Each one designed to correspond to a future Bitcoin block. So there's like a one-to-one mapping between the transactions they create and the Bitcoin blocks that are coming out as we progress through the future. So once they have these Bitcoin transactions, they leave one field in the Bitcoin transaction blank, which is the op return. They create an op return, but they don't fill it in. And if you do that, then anyone can take their transaction, which is a perfectly valid Bitcoin transaction that just needs a 32-byte string. Anyone can take their Bitcoin transaction and fill in the missing field, and then publish it when the corresponding block comes. That allows you to have a prepaid Spacechain that will last all the way until they run out of money. All the way, it'll just keep on spending down the prepaid balance until it's gone, and all of that money will be used for fees, for transaction fees. And you can use that to enable a Spacechain to last for a certain amount of time before it runs out of money, and then it's good. Then you had a space chain, you had a sidechain that lasted a certain amount of time. That could be useful. Could be useful for like futures contracts, DeFi stuff. Not everything needs to last forever. And if people want to keep it going after it's done, you can just start all over. Crowdfund a new space chain and start going over again. The difficulty is, or there's two downsides of this one. One is that if all the sponsors wanted to, they could just steal all the money that they crowdfunded, because they, at least at one point, they had all the private keys. In order to reduce that trust, or in order to reduce that possibility, at least one of them is supposed to delete their private key. As long as at least one of the sponsors deletes their private key after they create all the Bitcoin transactions, then they can't steal anymore, because you need all the private keys to steal the money. So that might be okay. Some people might be okay with that. I probably would, because of the thing I'm about to show you in the next slide. But it has an expensive upfront cost. The other thing, in order to make a prepaid space chain, you have to know how many blocks you want it to live for, and then crowdfund enough Bitcoin to pay all the mining fees for it. However, I told you earlier that there are two new slides in this presentation, and we already went through one of them. And this is the new one. This is the new slide. So, yay! We might have figured out a way to use the prepaid model, which used to be the worst one, to do something that's kind of a little bit like a two-way peg. So if you remember, a one-way peg is where you destroy your Bitcoins, and you put a record of that on the sidechain. That counts as the new coin. It's the new, the space chain coin, space coin. And I don't like that because I don't like destroying Bitcoins. But Ruben Thompson came up with a way to mitigate that. And it only works with the prepaid model. But if you use the prepaid model, then the sponsors who are creating the space chain, in addition to crowdfunding enough Bitcoin to pay for transaction fees on it, they can also crowdfund enough money to be the only peg-in that is allowed in this space chain. Everybody pegs in all at once. And if you do that, if everybody pegs in all at once, you say, I want to have 1 Bitcoin on this space chain, so you send the 1 Bitcoin to the sponsors. If you do that, then you can gradually leak that money back to the main chain through just bigger transaction fees. And that's kind of a little bit sort of like a two-way peg, but not really. It's kind of like miners are able to peg out, because if miners put money in, miners are getting that money back as it comes back to them in transaction fees. And so miners will be able to peg in, and miners will be able to peg out, and it would be a little bit like a two-way peg, except most people wouldn't be able to do it. It would just be miners. So I want to build this and see if it's any good. I don't think it'll be very good, but maybe that could be interesting. But yeah, we haven't built it yet. But it's sort of this idea that you can have a two-way peg if miners peg in some money and then it leaks back to them over the course of the lifetime of the space chain. The other problem with this model is that you ruin the price cap. If everybody has to crowdfund in just once at the beginning of the thing, at the beginning of the space chain, then you don't have that price cap anymore that's built into space chains by nature of anyone being able to peg in at any time. So if we go back to this example here, where the lady's like, please buy my space coin for 1.2 Bitcoins, the blue guy can't anymore say, I can make my own. Because if you're using this sponsor model, where everyone crowdfunds it at the beginning, he doesn't get to peg in at any future time. He can't make his own space coins after that. He missed the boat. So finding a way to recreate that situation where there's a price cap would be really nice. But until then, I don't know what to do with this one. I do want to try and build it and see if it's any good, but I'm skeptical. This is kind of the state of the art with the space chain design space is to make one that leaks back to the main chain, and then is a little bit like a two-way peg, or at least we can see if it's like one. So y'all who are developers should help me build it, and then we can see if it's any good. Governance fix a lot of things with space chains. You got a question or a comment?
How do you actually stop anyone? How do you stop more people from taking it? Could anyone just send more money to it, or just missing firms?
Yeah, you just have the software not recognize any additional peg-ins after the initial one. So the question was, how do you stop people from pegging in after the initial crowdfund? and you just design the software so that it ignores future attempts. Okay, so covenants fix a lot of the problems that Spacechains have. Covenant, of course, is a software that's, well, there's like 10 of them now that have been proposed for Bitcoin that allow you to specify outputs in your logging script, which, if you're not a developer, that's similar to creating a whitelist. You can create, if we had covenants, you could create a Bitcoin address where you put money in it, and there's a whitelist in the address that says if you want to spend this money, you have to send some of it to address A, address B, and address C. They're on the whitelist. You have to spend some amount to those addresses, and then you can do whatever you want with the rest. That's what covenants basically do, is they let you create, like, some people call them cursed Bitcoins, where you put Bitcoins in this address, and they're cursed, they have to go to this whitelisted set. But if we had those, they would fix a lot of things in Spacechains. They would, first of all, they would make it so that this trusted setup thing with sponsors, you would no longer need to trust them. You wouldn't need to have an n-event multisig, you could just use a covenant, and then the coins would be forced to pay out to miners over the course of the lifetime of the Spacechain. It would just be cursed to do that, and there'd be nothing the sponsors could do about it. So that would be an improvement on this model, because you'd be reducing the level of trust. And it would also make it so that you don't have to trust them with the other set of Bitcoins that you're using for the leaky two-way pay. You wouldn't have to trust them to like hold on to that money either, because it would all just be cursed to go back to miners. So covenants would fix a lot of the problems with Spacechains. They would also fix the problem with the anyone can spend model, where somebody can just take the coins. If they were cursed to only go back into the same address over and over again, then no one could steal them. The transaction would be invalid if you tried to do anything but put them right back into the same address. You got a question?
Yeah. Is anyone can spend model still relies on author return? Is there any way to prevent DOS attacks where this anyone can spend output can just be mined without a merge mine hash?
The question was, is there a way to prevent someone from putting like a fake hash or just a bunch of zeros in where the operand is supposed to be? No, you can't prevent that, but it's not a big deal because of something that Satoshi invented a long time ago. When Satoshi made Bitcoin, he made it so that as you're downloading Bitcoin blocks, before you download the block, you download something called a header, which tells you like it's a hash of the block, and it tells you like all the zeros and stuff. And since you download those before you download the blocks, some people sometimes send invalid ones. They'll like create a block header that doesn't have the right number of leading zeros, or does, but there's no corresponding block. And when your client gets one of those, it then requests the corresponding block, and if they can't provide one, or if they provide an invalid block, you just ignore that header and move on to you just ask someone for a replacement. And you can do the same thing with Spacechains. If somebody puts in an op return that's just all zeros, you would request a block that hashes to all zeros. And if they can't provide one, you just ignore it and move on to the next op return and use that one instead. So that allows you to overcome the problem of somebody just putting fake data in there. You just validate the data, and if the data is not valid, you ignore it. So yeah, that's the answer to that. Does that make sense? Not quite.
So you're pre-computing, in the prepaid model, you're pre-computing a bunch of transactions that have this data blank, right?
In the prepaid model, you are creating a bunch of transactions that have the op return field blank.
So couldn't those all be burned and you run out of fees?
The question is, could all of those be burned by putting in like invalid data and then run out of fees? You could if there was no competition to create valid ones. Because in theory, the transaction that pays the miners the most in fees should be the one that they accept. And people who are mining on the Spacechain have an incentive to create blocks that actually have a bunch of transactions in them, because that's how they get their income. And so they're incentivized to like pay more than the trolls can to get actual transactions mined. Does that make sense?
Yeah.
Okay, cool. Okay, so that's what covenants help us with this a lot. And if we get covenants, we'll be able to have better Spacechains that approach. We can start to make them a little bit more and more as good as drive chains, but we're not there yet. Okay, so some use cases for these things. How much time do I have? I have 25 minutes. So we're good. We're going to do the last 20 minutes doing the demo. So some use cases for these things. If we made them and they were any good, they could destroy all altcoins. Actually, even if they suck terribly, they could destroy all altcoins, because altcoins suck worse. So I propose making Spacechains like the ruined kind that we can make today. We should make those, and even that would be enough to kill all altcoins, because altcoins are just a weak enemy. Like if you could take like a Monero, for example, and turn it into a Bitcoin space chain, where you could take your Bitcoins and by means of the sponsors, you put them into this Monero sidechain, and you can do your private transactions and stuff, and then just like sell your Monero Bitcoins when you're done. That would be great. And because of the sponsorship model, miners could even do like a one-way peg in and peg out thing, which would be awesome. That might help keep the coins equivalent in terms of value to Bitcoin. Or if you could do that with Ethereum, you could just copy Ethereum, make it a space chain, and have people, buy space coins, sell space coins, and then use it that way. So I hope we can make space chain versions of all altcoins, and then just put them head to head and see which one people like better. Because I think the ones we can make would be more secure than the ones that people are using, and they wouldn't actually be like speculative assets. They would you'd just be using. You'd be using these Bitcoin or these side coins instead. You could use them for domain name records. So this domain name records don't actually need a token to represent them. You actually just need the record of who registered a domain name first. So you could use them for that. I don't like stablecoins and NFTs, but you could use Spacechains for those, because those also don't need a those do need a specialized token. So you'd need to do with a sponsorship model or something. And maybe if we have more people experimenting with Spacechains, the other thing that would excite me is more people might try and figure out a way to fix the one-way peg problem, and we might come up with better solutions to approach a two-way peg. So I hope that more people do Spacechains so we can do that. I want to do a quick comparison with two-way peg models. So there's 3 different two-way peg models that actually that I want to compare it to. One of them is a federated sidechain. These are already exist in Bitcoin, and they're pretty good. Liquid is one, and Rootstock is one, and I think they're kind of neat. But two-way pegs, they involve sending your money to a group of people in an M of N multisig, and then you have to trust that that group of people will give you back your Bitcoins when you're done. And that works today, and so far no one's had their money stolen from them by Liquid or Rootstock, so that's pretty good. And you don't need a soft fork to do that stuff, we can just do it. They work. So I want to see more work done on those things. In comparison, a space chain is interesting because depending on what model you do, you place less trust in the multisig. Well, in every model, you place less trust in the multisig. Even in the sponsored model, just one guy has to delete his private keys and then they can't steal anymore. So that's better than a regular multisig. So that's my opinion. I like space chains better than federated ones. And then there's drive chains. I personally like drive chains better than space chains, but they require 2 soft forks to get them in. You need the BIP 301 soft fork to do the blind merge mining. That's more efficient than the kind we can do with all the drawbacks, the kinds I talked about earlier. And you need BIP 300 for an actual robust two-way peg that doesn't rely on leaking money back to the main chain. So that would be better, in my opinion. If we could get this, that'd be great. But we can start with space chains now, so that's kind of nice. And then the last one I want to compare it to before we do the demo is a rollup. A rollup is a type of blockchain where instead of putting a hash of the sidechain into Bitcoin, you put a zero-knowledge proof of all of its transactions. Zero-knowledge proofs are a little bit bigger than hashes, but you can do mathematics on them to prove data about what happened on the sidechain, and that's kind of nice. But these also need a soft fork because they rely on us having this ZKP verify function. We're not entirely sure that's necessary. I kind of have this theory that it might be possible to build one using Bitcoin's Boolean functions, but that's for some future, 7 years from now, maybe that'll be done. In the meantime, we would need, if we can't do it already, then we would need to add a soft fork for it, and that soft fork suck. So I would rollups, that'd be cool, but they take a lot of work to get into Bitcoin, and no one's even written like software for doing ZKP verify stuff. So, my opinion, that's Spacechain compared to those three. And these are the references. If anyone wants to check out all the details in this presentation, you can view these links, or you should all have it on your laptops now, and then you can do that. Are you guys ready to do the demo and actually launch a Spacechain with one another?
Yeah.
Okay, let's do it. We're going to make one. Okay, so this is the place where you can make your own Spacechain. So I encourage you to come here and let's get it done. There's a couple of links that tell you a shorter, presentation on how Spacechains work. Maybe if you're working on one and your family's like, why have you been in your room for 10 weeks? You can like send them one of these videos and be like, I'm working on this, it's amazing. But yeah, we can make one, or we can view the first Spacechain ever. And I would rather make one than view the first one, especially because this button doesn't even work. All right, so let's make one. What do we want to call our Spacechain? Somebody come up with a name for it, and then raise your hand. Janet, what do you want to name it?
Laser.
Laser, with an S or a Z?
A Z, of course.
All right, we're going to name our Spacechain the Lasers. It's just going to be laser. And we need this is optional. Do we want to have a Genesis message in the first block? Anyone have one that they want to put in?
Lasers kick ass.
I'm not writing that. This is a family-friendly blockchain. And also wash your mouth out.
TabConf is cool.
TabConf is cool. All right, cool. So that's going to be our block, and we'll say yes, that's what I want it to look like. It gives us a little visual representation of the block where I show off my CSS skills. Gorgeous, let me tell you. And we need to pay for it. By the way, I want to mention, because I don't like burning Bitcoins, we're not going to burn any Bitcoins with this Spacechain. You don't need to, and so I'm just not going to do it. Cool? You all cool with that? Also, this is only running on testnet, so I couldn't burn any real Bitcoins if I wanted to. But you do have to pay Bitcoin miners to take this piece of data and add it to a Bitcoin block. So that's what I'm going to do. I'm going to copy this. I'm going to go to my favorite Bitcoin faucet. And then I'm going to put some testnet Bitcoins in it. And how much does it need? It needs 846 sats. It's nice that fees are low on the testnet. So let's see, is that? Yeah, that's right. So we'll send that. And that particular faucet takes like 30 seconds or so to actually show up on here. So while we're doing that, I'm going to read you these rules that I was supposed to read before I clicked and didn't. It says your Spacechain will be stored in your computer only. So I'm doing all of this on the client side, and when you're like on a blockchain, you have to like store the blocks somewhere. And I store them in local storage. Like I store them in your browser's local storage. So don't use this for anything serious, because there's only like 5 megabits of storage in local storage, 5 megabytes. And if you get to like 100 blocks or so, there's just no more room, and it'll crash and not work anymore. But hey, it fixed, or it finished. It found the transaction. So if we go look at this transaction in a block explorer, mempool space / testnet, we will see that we have our transaction was made. We put 846 sats in. We used 300 sats to pay for a fee, and we put 546 sats in an anyone can spend address, which looks like this one. And then in the details, we've got a little hash over here. That little hash right there is the hash of our sidechain block. So the little message we put, this is a hash of it. If we click OK, then our sidechain will show up right here, and we can view it. We can view block 1. Its hash is this. It's anchored into Bitcoin in this Bitcoin transaction, OC6A. That's right here. You can see the transaction ID is OC6A. So that all works. And yeah, we paid a fee of 300 sats. It's not a very big block because it's only got one transaction in it. And the transaction is just kind of like the first, kind of like the Genesis message in Bitcoin. It's just a piece of text. It says the name of our Spacechain and its little message here is TabConf is cool. So we've made our first little space block, and if we want to make the second block, well, we have to wait for this one to actually get mined, because This it's still in the mempool right now. Oh wait, no, it already got mine. Look at that, it's already mine. We can make the second one. So cool. So let's make the second block real quick. Register as a miner of the Spacechain. And then what do we want our second transaction to be? It supports transit the transaction I previously did was just a piece of text, which is perfectly valid in both Bitcoin and Spacechains. You can make transactions just text. But you can also use these two buttons to burn testnet Bitcoins and then create burned Bitcoin Spacecoin transactions. But I'm not going to do that because I think it's stupid. So the only thing you can really do with this is put more text into the sidechain. But any piece of text can be a transaction. So let's make a new one. Anyone want to say what the second transaction in our Spacechain should be? What should it say?
Super testnet is awesome.
Well, I thought Robin Linus is awesome. The guy who said that is Robin Linus, for those who aren't aware. So that'll be our next one, and then we can do another one just for fun. What do we want the second one, the next one to be?
Hi, Mom.
Hi, Mom. I made a Spacechain. All right, so now we'll just mine the second block. Not register. Well, it looks like I have a bug. What's going on with the, something's undefined. Well, that's sad. This part's supposed to work, but apparently I have some bug fixing to do. Anyway, you just do the same thing we did before. It would show you a Bitcoin address, you'd pay the thing, and it would take the hash of the block and put it in Bitcoin. And then we'd have our second thing. But apparently there's a bug and it doesn't work. Let me just try refreshing, maybe that'll do it. Unregister, refresh, mining center, register, hi Mom, and the other one was, I forget what the other one was. Oh yeah, Robin Linus is awesome. Nah, it's not working. Something broke. So, but yeah, it would do the same thing. It would show us a QR code for 846 sats. We'd pay it, and that would go into this block of Bitcoin, or Bitcoin's testnet. So that allows you, by just doing this over and over again and spending the money in this anyone can spend address to do it, you can just go forth and make your own Spacechains. And if you're worried that people will steal from it, just have a popular Spacechain where people pay you to put transactions in, and then you can outbid the trolls to spend that money and keep your Spacechain going. And it's great, and we can use this to clone all altcoins and make something even better than they are. Of course, it'll need to work. For some reason, this isn't working. But yeah, that's basically it. And we have 10 minutes left for questions. So are there any questions about Spacechains and how they work? Portland, I got one.
What are you using for the input and spend script? It looks like push bytes followed by your desired hash.
Okay, let me show you what I'm using for it. So the first thing we do is we do an opt drop. So this is the anyone can spend script, and the opt drop just removes the hash of the sidechain, because all that's there for is for us to commit to the block. We don't actually need it for any part of the script. Okay. So we just drop it. Then we take a SHA-256 of the previous value right there, and we compare it to this. I don't know what that one's doing. This is the input. Yeah. Well, no, I'm sorry. This is, you're right. Yeah, okay. You're right. This is not the right one. So if I go to this thing, there's been a whole bunch of transactions into this address, and the top one should be the latest one. So this one should be. No, this isn't the faucet. This is me spending from the coin. The faucet sent me 846 sats. So I'm spending that output to put 546 sats into the anyone can spend. But I'm not sure what this second thing does. I don't remember writing this op equal op if thing.
That's fine. That's the faucet proving that it's. But
this isn't the faucet spending it. This is me spending the coins the faucet sent to me. So I don't know what this is doing. I'll have to look at my code base. But the next thing it does is it has an op check lock time verify, which ensures that this transaction is only valid in a subsequent block. Like, we have to make sure that you can't like put a whole bunch of sidechain blocks, anchor a whole bunch of sidechain blocks into one Bitcoin block. So we want them to progress one by one. And so we use op check lock time verify to ensure that we're always in the subsequent Bitcoin block. So they go one by one. So that's what that's there for, and then we drop it. And why is there a check sig though? There shouldn't be a check sig. I thought I designed this to be just op1. Let me go check my GitHub. GitHub.com, super Spacechain launcher. This is the GitHub if anyone wants to check that out. And everything for the Spacechain, including the block explorer, is all in this single index.html file. That's how I like to do it. So I think the function for this is going to say something like generate. It's not the oh, that's what it is. Okay, it's an HDLC. When I designed this, I took some of the code for it from a previous project I'd done where I used HDLCs. And I think what I did, in order to not have to rewrite, because I'm an idiot, I think what I did was I made it so that the private key to this anyone can spend address is known. It's like published.
Okay.
And since you know the private key, you can always take the funds from this HDLC.
That would make sense.
Yeah, so this thing up here is the other byte value here is a pre-image, which you're hashing and then comparing to the other item. And since you know the private key and you know the pre-image, you can always sweep the funds. But then I didn't, I did this, I guess, so I didn't have to rewrite any code. It would have been simpler to just make it op true. So I don't know why I did that.
0 multisig is also.
Really?
Yes.
Oh, that's cool. But
Yeah, it's 3 bytes. Op 0, op 0, op.
But op true would be 1 byte, so it'd be better. But yeah, that's cool. I didn't
It's
know
not
0 multisig is cool. So yeah, this isn't anyone can spend address that's wrapped in an HDLC, which is stupid and expensive. But yeah, it works. It worked. I mean, it did work. It worked every previous time I've done this. So any other questions about how this works? Robin, what's your question?
Go back to the script, please.
Okay.
That drop makes the transaction valuable, right? Like, you send a transaction and you want to inscribe your block, and you broadcast it.
Yeah, someone could malleate this.
And I can take your transaction and make you pay for my block.
I didn't realize at the time that would be a problem, and that's why in the state of the art we use op returns instead. Because you can't malleate it if it's not returned because it's signed by your signature. No, it's not. It wouldn't be signed by your signature. You may have just ruined Spacechains. Next question.
You asked something along the lines of, would this two-way peg make the Spacechain be any good? What do you mean by any good?
Would it have a robust one-to-one peg between the price of Spacecoin and the price of Bitcoins? And would you be able to use it to destroy all altcoins? That's the scientific definition of what counts as a good sidechain in Super Testnet's book. Any other questions? Okay, well that's it. That's my presentation. Thank you for attending and learning more about Spacechain.